Well, this is a little embarrassing. This morning I said in my video on Pi Silicon that Raspberry Pi 5s can't go beyond 3 gigahertz because of the PLLs on the chip. However, I found out right after posting that video that that's wrong. I found out that there's actually firmware you can flash to here to let you go beyond the 3.0 gigahertz clock limit. So I'm going to try that. This is the only Pi 5 I have that gets to 3 gigahertz without any problems. It actually runs benchmarks. So it has a good chance of maybe getting to 3.1, 3.2. We'll see what we can do. And to do that, I'm not just going to use this Pi cooler. I'm going to use the Argon Thermal Tower Cooler. The reason I'm going to use this instead is because this cooler has phase change. It has like heat pipes in it that take the heat away from the CPU really quickly and bring it up. That keeps the temperatures a little lower, even at base clocks, than a cooling solution like this that slowly builds up the heat in the heatsink and then the fan blows it away. So we're going to see if this will get us any better performance, and I'm going to flash the custom firmware on here, potentially blow up this Pi, and then I won't have any that go to 3 gigahertz, but we'll see. This tower cooler, I actually installed it before. That's why this screw just fell out, because I put it back the wrong way. And just really quickly, it's the Argon Thermal, THRML. They forgot to put in the vowels, I guess. The 60RC. They sent me this, so this is not a sponsored video, but they sent this for testing, and it is so far the cooler that I've found that keeps the Pi the coolest. But we're going to put this on here with some thermal paste. It comes with this little snot in a bag or whatever, but I usually use my Noctua paste. I bought this like two or 3 years ago, so it might be getting a little old, but it also has a thermal pad for the IC. So let me get that out. The world's largest needle nose pliers for the smallest job. My small pliers are in the other room because I'm restoring some old Macs, and they're not in here. But I'm going to go get them anyway because I don't want to break this. This is probably the most annoying part of the designs of these things. Little plastic bits that retain all these little cooling devices are usually pretty tight in there, and you need a tool to get them out. So it's kind of a one-way operation. There we go. And then you gotta poke it out. Make sure you take off this film if you get one of these. Otherwise, it won't work at all, and that'd be silly. This is a very small SoC, so you want just a dot, not a lot. Doesn't look like there's a whole lot of thermal contact for the PMIC now that I'm looking at this closer. So it does something, but probably not that much. It helps, but it's not like it's doing a huge amount. I'm going to tighten one a little bit and then go back and tighten it all the way, because we want as even of pressure as we can get. Okay, and there's a tiny bit of board flex, but it's pretty solid once it's all in. And we got to get the fan connected. Okay, we have our little fan tower cooler for the Pi 5. You can see. Now the first step in this overclock is to, let's see, where is it? Yeah, this might be more official someday, but right now there's in a link on Raspberry Pi's firmware repository, there's a link to rpi EEPROM recovery.zip. I downloaded that, and it just has these 4 files in it. So this is a way that you can update the firmware on your Pi. You basically go into Imager, do no filtering, choose OS, and you're not actually going to choose an OS, you're going to erase the card. And I'm going to choose this SD card that I have. It's just a little SanDisk Ultra or something. Erase it. And then, so I'm going to go to the card that I just erased. You can see there's 16 gigs available. I'm just going to copy these 4 files over to it. And then eject the card. And take it out of my card reader. Put it in the Raspberry Pi. And I'm going to plug in the monitor. You don't have to do that, but it's nice to be able to see what's going on. So I have my monitor plugged in over here so we can see what happens. But you can also just watch the little LED on the Pi itself when it does its flashing. But with that in, it should automatically flash. And I'm going to plug it in and then quickly move the camera around so we can see what happens. So here we go. But that should start flashing if it's successful. There it goes. And then on the screen, it just turned green. That means that it overwrote the EEPROM with the new one. And this Pi should be able to overclock beyond 3 gigahertz now. Let's take that out, put PiOS on another micro SD card over here, and then we'll boot it up and see what happens. So you can hear how loud that gets at full blast, but it should start booting up PiOS. Here it goes. And I'm just booting at the default. It's the 2.4 gigahertz clock right now. We're going to go in and change that around and see how that works. Okay, the Pi is booted up. I'm going to SSH into it. Pi at, what is it? Pi5 cooling.local is what I called it. I'll try neofetch. And neofetch just reports the clock that the ARM is reporting. It's not the actual clock. It's just what the maximum clock is possible based on the config.txt value. So this could be wrong. I could clock this up to 4 gigahertz and it would show 4 gigahertz even if the clock wasn't measuring that speed. So if I say vc gen command measure clock ARM, this is showing me the current clock speed. So this is 1.5 gigahertz. If I say watch, and then I go in a new window, and I could have used tmux, but SSH into the same one and say stress ng C0, that stresses all the CPU cores. Now it goes up to 2.4 gigahertz. I'm going to stop that, and let's go back over here, and we'll say sudo nano boot firmware config. And at the bottom of this file, I have some overclocking stuff set up. So I'm going to add this over voltage delta. That gives more voltage to the CPU, to the SoC, the cores in there. And then I'm going to get it back to 3 gigahertz, and we'll see how that works. And let's see if it boots up. So reboot, and the Pi is rebooting over here. I'll show what the screen says. And yes, today is a Pepsi day. Sorry for all you Dr. Pepper fans. Here it comes. And usually when there's problems, it's around this time, it will show some kernel exceptions and crashes and oopses and things. So it looks like it booted up without any errors this time. That's a good thing. So I'll log back in. And if I do the same thing and watch the clock speed, so it's 1.5, that's the base, I guess, here. And if I go to stress again, it goes up to 3 gigahertz. And since it's still doing stuff and not crashing, that's a good sign. And we can also look into dmessage to see if there were any errors. There weren't. So I think we're safe to try to go further. Let's see what else we can do. I'm going to go to the config file, go down to the bottom, and let's give it 3.1 gigahertz. This would be the fastest I've ever seen a Raspberry Pi 5 go anywhere, if this actually works. Okay, so reboot, and let's see what the Pi does. When that fan goes, you can actually feel a pretty good amount of air in the back. It's not hot either. But that's a good sign. Let's see if we get any crashes. I do see a little bit of weirdness up here. That hasn't happened that I've seen. So we are getting into uncharted territory here. But let's see what happens when we log in and try running that stress again. Okay, I'm going to log in and run stress. And we'll see if it gets 3.1 gigahertz. There we go, 3.1 gigahertz. Okay. It seems stable enough. The fan on this thing isn't even running. I'm going to see measure temp, or is it get temp? I don't remember. Here. Wow, that is crazy. I don't understand how good, like, I mean, it is a big cooling solution, but this thing it's not that big. It's keeping the thing down below 40 degrees Celsius running full out at the highest clocks. But let's keep checking that. So 3.1 gigahertz. It seems like we have enough thermal headroom. We can go a lot further. So I'm going to change this again. We'll see how high we can go. I'm going to go up to 3.2 gigahertz. Save that. and reboot. Okay. And yeah, the fan has not even kicked in yet, even running at 3.1 gigahertz for a minute or so. The heatsink's still not even warm. Let's see what happens here. Okay. Still stable. Enough. And we're booted up. Let's log back in, try this out again. Okay, log in, run stress, 3.2 gigahertz, no lockup. Well, I don't know how far we can go, but we're going to keep doing this. Let's keep doing this cycle. Go to config, 3.3 gigahertz, and reboot. Okay, it's rebooting. There's a little bit more of that little question marks and things. And I don't see the cursor blinking anymore down here. So I wonder if we're hard locked up at this point. I think we might have hit our limit at 3.2 on this one, but let's, I'm going to hold down the power button, shut it off, and we'll try again. And it locks up down here at this on-demand CPU governor, because I think that's when it starts testing its clocks. And that's when it starts having problems if you have it clocked too high. See, we have a blinking cursor. Oh, here we go. So I think that clock on this particular chip is not going to get up to 3.3 gigahertz. We have, let's see what it says this time. Translation fault. It looks like it was at get page from free list. It's always at a different point when you're having trouble with the clocks on these things, but there's our, I always like seeing oops, and also when it says like it's doing things with jiffies, because I think jiffy is just a fun word, not just because it's related to my name Jeffrey, but Jiffy and Jeffrey are kind of just funny words. But let's go back to 3.2 gigahertz and see if we can get a world record Geekbench run on here. And to do that, because it won't boot up anymore, I can't just do it over SSH. I actually have to shut down the Pi. So I'm going to hold down the power button. Hold this down. It is nice to have a power button on the Raspberry Pi 5. That's probably the biggest convenience out of everything. And the speed is also nice, but having a power button when you're testing something or when you're building something new, that is so helpful. But I'm just going to pop that in there and then go into the FAT32 volume on here and open up config.txt and change it on my Mac. So I'll change that back to 3200, which was the last kind of stable frequency. And we'll put it back in the Pi and press the power button. Here we go. We still got those strange characters in there. Surely related to going faster than the designed limits of the processor. But we're not locked up yet, and that's a good thing. Let's log in and run Geekbench on here. So first I'm going to confirm again that we're stable. I'm going to log in here and run stress. 3.2 gigahertz. Doesn't seem to be an issue. And again, if I watch the temperature, it's 38. Yeah, and the fan has not spun yet. Here we go. And this time Geekbench is picking up 3.2 gigahertz, but it's actually 3.2 gigahertz, and it's not lying. Oh, you know what? I think I might have just blown it up. I was already running stress on here at the same time as running Geekbench. And yeah, it's locked up. I'm going to start it over and not be running stress while I'm running Geekbench. So rather than bore you with another hour and a half of debugging where I went through cycles of trying different settings, whether it was the clock frequency, the overvoltage, force turbo, all these different settings, I'll just get to the end. Basically 3.2 gigahertz was unstable. It would always start and then get stuck on ray tracing every time, no matter what settings I had. 3.14 gigahertz was my next benchmark, and I tried so many different ways, and after about 20 different tries, it finally ran through and was stable enough to finish a test. It finishes about 1 out of every 3 tests with force turbo turned on, which basically says always run at the highest clock speed. Don't try to use DVFS and scale up and down. That can lead to better stability for overclocking. I also set overvoltage to 8, which is not recommended. You should use overvoltage delta, but I just said give it all the voltage you got. I'm giving her all she's got, as Scotty would say. The highest voltage you can give is 1 volt, unfortunately. There was no way that I could get past that. And talking to Raspberry Pi, it sounds like that's like a chip safety limit. They care about things like fire and breaking chips and things that I don't care as much about because I just want to get fast speeds and high numbers. But because of that voltage limit, unless you are the best winner of the Silicon Lottery and have the best BCM2712 chip ever made, you're probably going to run into those same limits at a certain frequency. For me, it was 3.14 gigahertz. Maybe I could get a run out of 3.2 gigahertz, but bottom line, right now, at this moment, today, I have the fastest single core score for the A76 on the Raspberry Pi 5 on Geekbench. That record will probably be defeated once more people start trying to overclock beyond 3 gigahertz. And I would love that to happen because, you know, the whole point of this video is to try to get people to experiment and do crazy things. Raspberry Pis aren't built to be fast computers. They're built to be hobby computers that can go relatively fast compared to old computers. But it's just fun. It's like building the Petabyte Pi project. You push it to the limit to see what things break, and then you can learn how to make things more stable and secure for the regular limits. Same thing with overclocking. Maybe we can find ways to make a Pi cool down better without using as much metal or without using a fan or all these different things. There's a lot of things you can learn from overclocking and how to provide power to the Pi if you're powering it through a PoE hat or through USB power adapters or through GPIO, all these different things you can learn by pushing a system to its limits. So that's why I'm doing it, and it's awesome that I got 3.14 gigahertz on Pi Day. But anyway, please have fun with that, and happy Pi Day to everybody. And yes, I know that Americans are weird and we have different date formats. That's okay. I personally like, I think it's ISO 8266 or whatever. It's where it's the year, month, day. That's my favorite way. But I'm also in area code 314, so it's definitely 314/Pi Day today. Until next time, I'm Jeff Geerling.